All right. So we finished up number 28. And the very last one that we got to was m minus 15, m plus 2. So I'm going to drop down there and have us do that one. Pick back up in your notes. Yeah. Thanks, guys. All right, so break time's over officially. Let's go ahead and drop the technology off where it needs to go, pockets, whatever. We're going to get back into here, and I again apologize. We just lost the entire recording feed, so I'm going to... Yeah, right? It's just like casually just mention, look what we did. Okay, so, but I do want to review this last part of number 28, m times m. Mr. Marco, m times m, what would that be? M, yeah, m squared, very good. Mr. Mauricio, we have 2 times m. 2m, very good. And the next one? Negative 15m. And then the very, very last one here, what would you have to put? Yeah, is it positive or negative though? Negative, good. All right, let's put the whole equation together now. So embarrassing. All right. All right, so Maria, what's the whole equation now, Maria? What's the whole thing put together? M squared, very good. What's next? Minus 13m, very good. And the last thing? Minus 2. Yeah, minus 30, good. That'll work. All right, y'all, that was pretty darn awesome. We just did another quadratic function. Way to go. Way to go on that. We are now multiplying our 2 lines together to come out with our quadratic function. Many of you will recognize this quadratic function. And it's something very, very straightforward. This is gravity. Right? This is just saying if you toss something up into the air, it's going to come back down. Okay? So this is just like gravity. It's just like tossing a ball into the air. So let's move. All right, 29. Cool. So we're going to get our first equation here. We're going to call it line 1. Line 1. And line 1 is going to be a graph. We're going to have 2 coordinate points for you. We're going to have 4, 8, 12, 16, 20. So make your graph 4, 8, 12, 16, 20. And do that again. Copy that again on the y side. 4, 8, 12, 16, 20. Okay. Now you've got all those pieces. First coordinate point comes over here to 4, 8. Second coordinate point comes down here at 20, 0. And that's line 1. So once you get your 2 coordinate points down, come on in with a straight line. Make it line. All right, line 1. Line 2. Line 2, they give it, it's a line for sure, they just give it to us in a different way. They give us 2 coordinate points. They give us negative 12 and 20. They also give us 4 and 12. And now here's the big difference. In number 28, we were multiplying. We were multiplying lines. Here we're not doing that at all. Here this is more like add, subtract. And that's why this is different. That's why these 2 problems are very different. And you need to know the difference between here. Multiplying 2 lines together will give you the curve. Multiplying gives you the curve. But just adding stuff together, all we're just trying to figure out is where they cross. There's still two lines. We're just adding and subtracting. We're just figuring out where they cross. So very, very different than number 28. Okay. Adding and subtracting lines. Let's put these coordinate points on. We have negative 12 and 20. So come out here to negative 12, negative 1, negative 2, negative 3. There's negative 12. And then go all the way up to positive 20. Now I'm going to box this dot in so it's different. Okay. This is line 2 now. And we're going to graph it on top of line 1. The only other thing we're going to do is graph this 4, 12 point. All right, so come out here to 4, going up to 12. Make your last coordinate point with a box. All right, guys. Drawing that line and label it line 2. There we go. We got 3 options for you today. We have lines cross, 1 solution. Lines are parallel, no solution. We have C. Lines are the same. We have infinite solutions. Three options for you today. Is that okay, Marissa? Is that better for you to copy? Okay. Not there. We're not. The whole point of this entire year with Mr. Denning is that you get to know. Oh, like right away? Yeah, you get all the Isn't geometry a little bit easier than algebra? It is. Some people find geometry easier than algebra. Because it's like angles and like, what's it called? Yes, it just depends on how your brain's working. Some people really get into geometry, some people really get into algebra. It depends. Then geometry is going to be your one. All right, guys. So, which case do we have here? What do you think, Miss Vanessa, on this one? Do we have lines that are crossing? Do we have one solution? Do we have lines that are like railroad tracks? We have parallel lines. Or do we have the same lines that are on top of one another? We have infinite solutions. What are you seeing here on your graph? Are you seeing one solution, no solution, or infinite solution? ¿Qué piensas, Miss Vanessa? ¿Es la B? ¿Y por qué? Muy bien. ¿Y por qué? There. You're gonna hurt yourself again. What do you think? We're gonna leave some maximum. Okay. Ooh. Okay. Okay, now take okay, something. Okay. Muy bien. Okay, so it's not A, it's definitely B. Because these lines are parallel, they never cross. But here's my point. If lines are parallel, so put down here, if lines are parallel, if lines are parallel, what's going to happen with the slope? They're the same slope. Good. Same slope. If your lines are parallel, you have the same slope. Now, we also have another case, right? We have parallel, but we also have perpendicular. Okay, if lines are perpendicular. If lines are perpendicular. Now remember, perpendicular lines don't look like little railroad tracks. They look like intersections, like where we cross. Perpendicular, 90 degrees. If lines are perpendicular, then the slopes are opposite. No, it's just an intersection. That's just a place, one solution where they cross. Yep. If they happen to cross at 90 degrees, that's the perpendicular. That's the only thing. It's kind of like a square has to be in certain, not a rectangle. Okay, so slopes are opposite reciprocals, and we're going to practice that. Slopes are opposite reciprocals. So let's take a look at this. We have y equals 3x plus 2. We have y equals 3x minus 7. How many solutions would you have with this one? Mr. Osio, how many solutions would you have here? ¿Es la A, la B o la C? Se cruzan. These lines are parallel. They have the same slope, right? So these lines are parallel. So what do you think? Yes, there is no solution. Good. No solution. What about if we did something like y equals negative 1/2 x plus 7 and y equals 3x plus 7? Mr. Jacob, what do you think about this? How many solutions do we have? Is it A, B, or C? Do we have one solution, no solution, or infinite solutions? Okay, so we are saying that these lines are the exact same lines and that they have infinite amount of solutions. If they are the same lines, they'd have the same slope and the same intercepts, right? So we don't have that quite yet. Which one should we pick, B or A? Okay, so if their lines are parallel, we know that lines that are parallel have the same slope, right? So do these lines have the same slope? Nope. So we can't pick C, and we know that the lines aren't parallel. We can't pick B. What's the answer that we should put here? A. There's one solution here. Thank you. One solution. All right, let's try another one. Y equals 1/3 x minus 2. Y equals negative 3x plus 4. All right, Miss Karen, what do you think about these two lines? Do we have no solution, one solution, infinite solution? We have exactly one solution. Very good. Also, what do we know about these lines because we see the slopes here? They do cross in exactly one place. Because they are what? Yeah. So what do we know if slopes are opposite reciprocals? What do we call those lines? Yeah, these are perpendicular lines. One solution, and these are perpendicular. No, sir. No, sir. Not during STAAR. Not during STAAR. Any other week. Not during STAAR. Okay, guys. So now we have three different examples here. We've got an example of a parallel line. So they have no solution. They're parallel right here. You're exactly right. They have the same slope. Now over here, these are one solution because everything's different. I can't talk over you, fellas. Everything over here has one solution because it's all different. Your slopes are different. And these are perpendicular. One solution. So before we take the STAAR test, we're going to get a lot of practice on these three different types of lines. That's definitely something we want to dig into before we test out here. All right, guys. We got two more. We'll take another break. We're going to do a domain function real quick, domain and range kind of thing. And then we'll talk through some exponential growth, cell dividing, that kind of stuff. All right, folks, come on over here to 30 and 31, and then we'll take our break. All right, number 30, we're going to do domain and range. Domain and range of this function. The function is y equals 9 minus x squared. On the STAAR test, they're going to start throwing you equations that you have never seen before. That is how it's supposed to happen. The reason why it's happening that way is because they know that you are using your calculator. So the type of equation they give you does not matter. All you're going to do is put it right in here. Everybody's using the calculator. Okay? So we're going to go over here to go into your y equals here, and put in your equation so that it looks like mine. 9 minus x squared is what you're looking for. Now, from here, before we go to the table, or before we go to the graph, go to the table first. Come on over here, press seconds, and then get into your table. All right, now which one's which? Mr. Antonio, is my x the domain, or is that the y? Which one's the domain? The x is your domain. All right, so we're going to say domain is on this side, and range is on this side. It says random. Okay, anyways. All right, so Mr. Antonio told us that the x-axis was over here, domain. So let's look at some of the numbers that we have on our table. Miss Karen, what are some of the numbers that you see here in the x column? I know, but can you see on the board? Okay. Yeah, so it looks like we have positive numbers, right? We have positives, 4s. Do we have negative numbers too? We got negatives and we got positives. Good, let's write those down. Let's glance on over at our range too. Ms. Giselle, when you're looking at your range over here, the y-axis, what kind of numbers are you seeing there too? Yeah, negatives and positives. But it looks like we don't go all the way, right? Like something weird happens. Like it was negative, positive, negative again. Okay, so let's do that. Negative, positive, negative. Cool. All right, now we can go do your graph now. Push this far right button and make it do the graph. All right, so let's talk about range and domain. Remember, your range and domain go from small, bless you, to large. Okay. So your domain and range again is x and y. All right, Mr. Jose. Mr. Jose. When we talk about our domain here, the domain side, what is the smallest possible x value you can have? Okay, so when I go back on my table, let's see if I can get an x value that's smaller than 0. Yeah, I can get a negative number. I can get -1, -2, -3. What's the most negative number I could have? What's more negative than 0? What's more negative than 100? Negative infinity. Good. So put your negative infinity over here on the small side. Good. Put negative infinity on your small side. Now let's go over on the x side again, but let's go on big side. All right, Miss Tanya, what is bigger than 0? What is bigger, más grande de 10, de 100, de 1000, de 100,000? Es más grande, más grande, más grande. Ah. ¿Qué es el contrario al negativo infinito? Infinito. Muy bien. Positivo, ¿no? Positivo. Muy bien. So, X está entre negativo y positivo infinito. Muy bien. Es de cuestiones de domain. ¿Por qué es X? Right? This is our X line. All right, now let's talk about range. Range is going to go down on the Y side. Miss Marissa, when you look at your graph here, what is the smallest possible Y value you can have? I can have a 5, a 4, a 3, a 2, a 1, a 0, a -1, a -2, -3, -10, -1,000,000. What is so negative that it's down here so negative? Negative infinity. Good. So small side, negative infinity. Very good. Miss Karen, what's the biggest possible Y value you could have on this graph? Más grande. Is it though? I don't know where it is. That's somebody else. Is it though? Look back on your graph. I go up to 1, 2, 3, 4, 5, 6, 7, 8, something. And then does it go any higher than this? Right? It comes back down. So what is the biggest possible Y value that you can have? And you can always remember, you can always look at your table to kind of see what that big Y value is going to be. That's fine. That's fine. But you recognize that there's going to be a peak, right? Of the mountain. And that peak, that's what we're looking for. All right, so estimate it. You don't have to tell me a number that's exact. Estimate it. That's exactly perfect. Yep. Great job. All right, so, and we know that it has to be less than or equal to 9. It has to be bigger than or equal to negative infinity, right? Y has to be between the small and the big. All right, finish up in your notes, guys. We're going to do one more problem, and then we take a break. Break. Okay? What am I? We're going to talk through mathematics in banking. Money. All right, so, and this is your exit ticket from yesterday. This is where we finished out. You have a student, so you have an account. You have a bank account. You have a bank account. Your equation of the bank account is y equals 5 times 1.012. Raise it to the x. Antonio. Come on. You got this. And all this is saying is asking you a quick question. What does the 5 represent? ¿Qué significa en esta ecuación es la 5? El 5. What does the 5 represent? All right, so we got a bunch of stuff going on here. We got these two numbers that we're going to talk about. All right, Mr. LCL, what's the first thing here? What's the first thing? Yeah, is this the growth or the starting balance? Starting balance or the growth? What's up? I don't know. I can't hear you. Okay, the thing that comes first in your equation, is it the starting balance or is it the growth? The starting balance? Yeah, that's right. That's why it comes first in the equation. There's your start balance. You will also know this word as a deposit. A deposit is the same thing. Yeah, Marissa, will you give that to Marissa? Okay, next up. This one over here is going to be your growth. And when you talk to a bank and they are trying to grow your money, they use a specific product or a strategy to do that. That is called the interest rate. Right? Because that's what you want. Every single one of the dollars that you work hard to earn needs to have a job. You need to put it to work. And most of your money's job right now needs to be going out and making more money. So your banks need to have enough of a growth rate to make it attractive for you to deposit your money in that bank. So that's what you want to. That's what you want to focus on here is getting this number as big as possible, the growth rate. All right, guys, we'll put 3 minutes on the clock. 3 minutes. Do a quick break if you want to update your feed or whatever else needs to happen right now. That'd be great. If you missed some of the notes coming up here, they're here on the front for you. I'm going to push pause on our video, or maybe it's just stop so we can make sure we don't lose it too.